Good morning, students. Welcome to IIT NEET or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 8th students for today's session. As you can see on the screen, or you are well aware, my subject is physics. We are in class 8. Our new chapter, that is chapter number 4. After completing the Newton's laws, today we are entering into the new chapter, pressure. So today is the session number 1. So the chapter pressure is a continuation of the force. Continuation of the force which we learn in the Newton's laws of motion. Because where there is a force is there is a pressure will come. The force and pressure are the almost connected terms. No force, no pressure. No pressure with no force, we can say. So for you also, see, as a student, somebody you put pressure, your parents will put pressure or force, your teachers will push on you to get the good marks, to get the good results. So definitely you get the pressure in your mind. So the pressure will come because of the force only. So in this chapter, it's a very small chapter. Within 2 sessions we can complete. We learn about, first we start with what is thrust or force, what is pressure, what are the applications of pressure, where the pressure is applicable, and little about the one step ahead about pressure exerted by liquids and gases also. So not only the solids, even liquids and gas also can exert pressure, which is explained by the Pascal's law, which is the famous law in pressure. So right. So when you move forward to our topic, right? So when you open your material, page number 66, right? So what we are going to learn in this chapter, you can see here. So these are the important topics what we are going to cover in the next 2 or 3 sessions, right? The first will start with what is thrust and what is pressure. Then applications of pressure, where pressure is applicable in our day-to-day life. The pressure by fluid. Fluids are nothing but both liquids and gases. I will explain later. Then law of liquid pressure. What is atmospheric pressure? Pressure of atmosphere. Pascal's law and its applications. Right? So these are the 5 topics which we are going to cover in today and next one more session. Right? Hope you all ready. Very interesting topic, because it is our day-to-day application. Everywhere we can see where we can see the pressure, we can see the application, right? So here, just once a simple explanation is given. We observe that a balloon filled with hydrogen gas goes up, but a balloon filled with air falls down. A small iron nail sinks in water. Huge ship made up of iron float. Observe the difference. To seek answers to these questions, we need to understand how liquid and gases at rest react to external forces. This involves the study of the branch called hydrostatics. Hydro means water. Statics means rest. Liquid at rest. When liquid at rest, exert on pressure. So these questions answers can be clarified by end of the chapter. Okay. See, when you fill the different gas in balloon, some gas will take the balloon to the height, some gas will take the balloon to the down. Air. Air is nothing but mixture of gases. Fill one balloon with the air, one balloon with the hydrogen gas or helium gas. what we observe is the balloon filled with the helium or hydrogen gas will fly, whereas the balloon filled with the air will come down. Right? Then one more example is given. When you take one iron nail, when you drop in water, it will sink immediately. But big iron ship is floating. What is the reason? Very interesting questions are these. Right? How these liquids are exerting pressure. So before going for that, we learn, I told already, we learn about what is thrust. Thrust is nothing but force only. Right? So thrust is nothing but the total force acting on normally on a body called thrust. On any body, what is the total force is acting? The total force acting on a body. For example, you see, I'll keep one book here. Say there is a book on table. This is table. Right? I place one book. On this book, various force will act. One is weight in downward direction, normal force, the force which external force as well as a friction force. So depend on which force is more. If all forces are balances, the book cannot move anywhere. But what we are note here is so many forces will act on a body. And these total forces acting on a body is called thrust. Right? The total number of forces acting on a body. Any body, suppose you are sitting, some force acts on you, gravitational force or your weight or some normal force or some frictional force, nature's force. So all these forces which are acting on you are called thrust. Right? For example, the weight exerted by the book placed on the table is a normal to its surface. Right? That is example what I told. So when you see thrust units, so since thrust is a force, its unit is same as force, that is Newton or dyne. Newton in SI system, dyne in CGS system. Clear? This is about the what is thrust. Thrust is nothing but total force acts on a body. So it is nothing but force only. The total forces acting on a body is called thrust. Clear? Then what is the gravitational unit of thrust? So gravitational means with respect to gravitational force. So it is measured in either kgf or kg weight. Kgf is nothing but kg force. Kg force or kg weight. Right? So this thrust is a vector quantity. It has both magnitude as well as direction. So normal units of thrust is Newton or dyne. With respect to gravitational force, the units can be written as kg force or kg weight, or you can write as gram force in CGS. Gram force and gram weight. Right? Clear? Right. Then come to our topic, main pressure. Thrust acting on a unit area of the surface. Thrust acting on units area, a particular area, how much force is acting, how much thrust is acting. That is, we can write it as thrust by area or force by area. So, pressure can be given by F by A. Pressure is equal to force by area. The force acting on a unit area. So, here pressure increases with force. If force is more, pressure is more. From this formula. If pressure is more, area is more, pressure is less. If area is more, pressure is less. Area is less, pressure is more, because they are inversely proportional. So many examples. That is example, for example, nail. When you are dropping a nail into water, as the nail is having less area, it will shrink. But ship will have a more area of surface. Because of more area of surface, pressure is less on that compared to the nail. Because of that, it will float. Very important. So many examples will give. So many applications you can see. Right? But simply you have to understand that pressure is a thrust per unit area or force acting on a body in a particular area. Clear? So P is equal to F by A, where P is increases with force, P is decreases with area of cross section. When you are inserting nail into the wall, the sharp edge only will keep towards the wall because area is less, pressure more will insert into the wall. If you keep the head part towards the wall and hit, it won't insert. That we can see. Okay? Now, so this is about the definition of force, that is force per unit area, thrust per unit area. So what is the units of pressure? So you know the formula, F is equal to P is equal to F by A. So pressure is equal to Newton. Newton by area is equal to meter square. Newton by meter square or dyne by centimeter square or Pascal, named after a great scientist. Right? See, Newton per meter square or Pascal or dyne per centimeter square. So it named after a French scientist, Blaise Pascal. Clear? So the radiation also there, 1 Pascal is equal to how many centimeters? 10 dyne per centimeter. Some radiation. It is a scalar quantity. Right? Pressure cannot be shows any direction. Clear? So other units of pressure is bar is a 1 unit. Atmospheric pressure also 1 unit. We can learn late. And we can have torr. Torr also unit. Torr, bar, ATM, atmospheric pressure. ATP you can say otherwise. All these are the other units which have some relation with the both SI unit and CGS. So pressure is a thrust. Total force acting is called thrust. And how much area the thrust is acting is called pressure. P is equal to F by A, which is generally measured in Newton per meter square or dyne centimeter square or Pascal or bar or torr or ATP, atmospheric pressure. So this is about the thrust and pressure. Clear? Right? Now we'll see what are the applications. Means generally where we'll see this part is applicable in our day-to-day life. So many examples you can see. There are 5 examples almost. See, animals like camel walk easily in desert as compared to the horses or donkeys. You might have seen either directly or maybe in movies. Camel comfortably walk over in a desert, even though there is sand is there. But neither horse or donkey or even human being also cannot walk. Simple observation. Why? Because they have broad feet. Broad feet exert less pressure on sandy ground. Broad feet. If you see carefully, the camel have the feet, very big feet, because of that is area is more. When force is acting on more area, what happened? Pressure is less. Area is more, pressure is less. So less pressure acts on the sand, so it is comfortably walk over the sand. Whereas to see horse or donkey or even human being, the feet is not much area, very small feet is there. Of course, donkey and horse is very less when compared to human being. Because of less area, more force acts on that and the pressure increases. So we will insert into the sand. For every step, you have to struggle. Where camel cannot struggle, it moves very happily over desert. Got? So, best example, best application is animal like camel easily walks in a desert as compared, right? As compared with the donkey or horse, because camel will have a broad feet. Broad feet means the area acting on more area. That's sorry, force acting on more area. When force is acting on more area, pressure will be less. Greater the area, lesser the pressure, because they are inversely proportional, as you know in mathematics videos. Whereas donkey and horse will have a small feet, less area. That is the reason more pressure acts on them. So it not feel comfortable to walk over the deserts. Okay, next one more is there. Second one, a heavy truck is fitted with the 6 to 8 wheels. You might have seen very big trucks which carries the very big weight, right? Containers. They'll carry the containers, big containers. You might have seen so many movies. Even the movie Pushpa, Japan, they'll send the containers through the ship and they lift and keep it over the lorries and all, and they'll carry. So such vehicles will have so many tires, so many wheels, 8 or 10 wheels. Why? Because they want to distribute the force into more area. More number of tires are there, more area, so that it can move fast. Right? This increases the area of the contact on which their weight acts. Hence, that reduces the pressure on the ground. See, wonderful. Why the lorries carrying the heavy luggages will have more wheels? Because they want to distribute the weight of the whatever you are carrying to more area. When there is a more area, less pressure, so lorry can go comfortably. Got? Very clear? So we can see daily. When you see in the roads also, you can find such examples everywhere. Of course, we cannot go to desert regularly, but you can see in the movies how the camels are walking, how the human being is suffering, walking over the desert. Right? Next. Third one. To see a third example, another interesting. The skiers. To see skating, roller skaters, skating, they use the skiers, very big plates. You might have seen in so many movies, or some of you may be doing. The skiers use flat and long skies to slide on snow. Because larger the area of the cross section, the less is the pressure on the snow. We cannot skate on the snow with our shoe. So what we'll do? We'll use the skies, very big skies with more area. You'll stand on that and you'll skate on the ice. Correct or not? Why the skies are very broad? Because to reduce the pressure. Right? Got? So before going for further example, let me show you one video on this. So what is thrust, what is pressure, and what is right?
Sanya, a 13-year-old teenage girl studying in class 8 who loves to explore new things. Mummy, Sanya's mother, a 40-year-old lady who lives in the city. She helps Sanya in exploring new things. Kabir, Sanya's elder brother, a 14-year-old boy studying in class 9 who helps Sanya in all her explorations. Oof, this is too heavy. Bhaiya, this table is so heavy. Can you please help me push it? I want to remove it from here.
Sure, Sanya.
Let's try moving this with both hands. It will definitely move then.
Done.
This was so not possible alone. Thank you, Bhaiya.
Well, pushing it together helped move table even faster.
Yes, I remember having read that to move an object you need to either push it or pull it. So does that mean that by pushing or pulling an object, we can actually applying force on it, is it?
Yes. Okay. Can you tell me where all have you used force since morning?
Let me think. Things like opening and shutting a door, kicking a ball, opening and closing a drawer, pulling out a book from the book rack. Friends, can you help me find some more examples?
So these are the
Sanya,
four
can
basics
you
of the
guess
pressure.
what will happen if you push the table from this side and I push it from the opposite side?
Oh, that is so obvious, Bhaiya. Either the table will not move at all, or whoever pushes it harder will be able to move it.
So what do you think? Can a force be more, less or equal to another force?
Yes, Bhaiya, like you are older than me, you will be able to put more force than me.
That's exactly what happens in the game of tug of war too.
Tug of war.
When two teams pull a rope in opposite directions with equal force, the rope doesn't move, and whichever team pulls with more force wins the game.
Bhaiya, I want to know more about force.
Oh, sure, Sanya. Let's find out. See, this is your childhood toy car. Can you push it gently to move it? Good. Now push it again with some more force and see what happens.
Bhaiya, it is moving faster now. Friends, this reminds me of the rubber tire game. The rubber tire had to be pushed continuously to make it move faster. Sanya, can you tell me what will happen if you put your palm in front of this moving toy car? The car will stop right here. Oh, so you mean if we apply force in the direction of a moving object, it will move faster.
Yeah.
On the other hand, if we apply force in an opposite direction, then either it will slow down or completely stop moving. Am I right, Bhaiya?
Absolutely right, Sanya.
Friends, can you also tell us some examples where force affects the speed of an object? We see such examples in the playground and very frequently. Can you list them?
See, all these are the cases of force applied.
Does
In
force
speed of
change
the-
only the speed of an object? What do you think?
Bhaiya, even I want to know about it.
Look at the people playing badminton outside. Can you find any difference in the impact of force there?
The shuttlecock went straight when hit by the first player, but it turned in opposite direction when hit by the second player. So friends, does this mean that the direction of motion of an object can also be changed by applying force to it? What do you think?
Kabir and Sanya, I need your help. Can you both come here?
Bhaiya, look at this chapati. Can you see how force is applied while rolling it? See how its shape has changed. The round dough ball has now become flat. Bhaiya, when I pull this elastic ring, then also its shape changes. Oh, now I understand. Some objects change shape when force is applied on them. This also happens when we press a rubber balloon or a ball. Oh, my ball, Bhaiya. Please catch it for me. Bhaiya, how is it that no force was applied on this ball? Then also it slowed down and stopped in the end? How is it possible? Does this ball too have some kind of force? Friends, I had read that to apply force on an object, there must be some interaction between the body and that object. Otherwise, a rope, stick or another object can be used to apply force. But here there is no such thing.
Sanya, what if it is not the interaction between our body and the object, but instead it is between the ball and the floor? Do you think it is possible?
Friends, can you help me with this?
Sanya, what do you think, can force be applied only by an interaction or contact between two objects? Do you know about the non-contact force?
Yes, mummy. I had read that gravitational pull is an example of non-contact force. When we throw a coin, it falls straight on the ground due to the gravitational pull. All objects fall towards the earth because of Earth's gravitational pull. Am I right, mummy?
Yes, Sanya. Can magnetic force also be an example of non-contact force? What do you think?
Let's try it and find out. We'll take these two magnets. If we bring like poles towards each other, these magnets repel each other.
And what happens when we bring the unlike poles towards each other?
Well, they attract each other. Do you remember we read about it in class 7? I get it. Magnets can exert force on each other without any contact. This is also non-contact force.
You are absolutely right, Sanya. Come, I want to show you something else too. Let's take this plastic comb and rub it in our hair.
Electric force.
Now bring it near the bits of paper.
Oh, bhaiya, this comb is attracting the bits of paper.
Sanya, now can you guess what kind of force will cause this attraction?
Bhaiya, is it static electric force? Friends, do you remember reading about a straw when rubbed with paper becomes a charged object? I think by rubbing this comb, a charge is created in it, which can apply force even when not in contact with other objects.
That also comes under
Am I right?
contact force, right?
You are absolutely right, Sanya. We learned what a force and how does it work. Properties of force.
Different types of
Force
forces
applied
will
in
explain
same
here.
direction adds up. One force can be more, less, or types of
Not much
force.
about the.
Contact force, non-contact force.
Okay, you will see the next part in the next about the pressure. There is no much is given here, so we'll discuss about the pressure in the next class. So here we'll continue various applications of the pressure. That video shows only details about the force only. See the third example. First two you have seen camel, and second one is you have seen how why camel. Then a truck contains 8 to 10 sets of wheels because to distribute the same weight into the more area. And third one, if you see, right, see, third will be there above. We'll see third first, then we'll go to the fourth. So the skiers were done. Okay, we have done with the skiers. So when you come to the fourth one, the cutting edge of the knives. You use the knife in kitchen for cutting the vegetables or fruits, right? Blades and axes are sharpened. Why you will sharp every time? So that when you sharp, what happens? The area of the contact decreases. The sharpened edge, not blunted edge. So as we are sharpening, the area of contact decreases so that you can cut the pressure is more. Area is less, pressure is more, right? So as the cutting edge is the sharpened, the area of contact decreases and hence the pressure exerted by it is increases. So thus they can easily penetrate through a given surface. So either we are cutting the fruits or vegetables or anything. So whenever this knife is sharpened, when you are sharpened, what happens? The sharp edge becomes the area becomes less. As the area is less, what happens? Pressure is more. We cannot cut with the reverse end. We cannot cut any vegetables with reverse edge easily. Why? Because there is a more area. So wherever there is a less area is there, the pressure is more as per the formula P is equal to F by A. Area is less, pressure is more. Area is more, pressure is less. They are inversely proportional. So in all these cases, same thing you can see. Right? Next. Foundation of high-rise buildings. Nowadays, we are getting the buildings of 50, 60 floors also. So buildings can easily penetrate through a given, buildings are kept wide so that they exert less pressure on the ground. Means their ground is very big. They should have more area at the bottom as you are raising. We cannot place so much building in a small area. The ground area for ground floor is a more area so that they can withstand the pressure. Because more area, less pressure. Okay. So as you know, that is because pressure is equal to thrust by area. So pressure is directly proportional to thrust and pressure is inversely proportional to area. All these 5 examples shows us, all the 5 examples shows us that pressure is more when force is more and pressure is less when area is less. So both area and pressure will affects the pressure acting on a body, which shows by all the 5 examples. It may be camel walking on the desert. It may be skiers skating on ice. It may be of a truck, how truck is comfortably moving on a road with more number of tires, and also these 2 examples. Right? So this is completely about the pressure exerted by the only solids we have seen. So pressure not only exerted by solids, pressure also exerted by the liquids, which we'll discuss in the next class. So, liquid or gases if you take. Of course, we cannot see gases, but you can experience and feel. Both as the molecules are very tight in solids, it cannot flow. When you place solid in one place, it remains there only. It cannot flow. But both liquids and gases will flow. Suppose drop some water on table. What happens? The water droplet will flow. Similarly, gas always flows from one place to another place. So that is the reason, as both are having the common property of the flow, liquids and gases together are called fluids. What they are called? Fluids. So not only solids like lorry or skier or a ship exerts pressure. Liquids also exert pressure. So in next class, we'll discuss about what is the pressure of the fluids. How fluids exerts the pressure. What is the how many kinds of pressures we can see in the liquids. For example, simple example, after going home, take one rubber ball and throw it in a water bucket. What happened? The ball will come up. Why? Because there is a pressure exerted by the liquid. That is called upthrust. Upthrust or force, one kind of force exerted by the liquid. Some of them may sink, some of them may float, some of them may partially float. But definitely there is a force exerted by the liquid. It may be either upward force or downward force or lateral force or sideward force. So many types you can see. Right? Suppose when you are sending air into the balloon, when you are blowing the balloon, because of the air pressure, balloon will bulge. You can see how the balloon is bulging because of the pressure of air. So air exerts the pressure in giving the shape to the balloon. Like that, both not only solids, both liquids and gases also will exert the pressure. Right? So these details of types of pressures and how they are exerting and how this is connected to the Pascal's law, we'll see in the next class. Right? So that's all for today. So today what we learn, if you just, when you see, just we started the chapter number 4 today. We learned first about what is thrust, right? What is thrust? That is a total force acting on a body is called thrust, which is measured in, as is a force only, we can measure in either Newton or Dyne. Then pressure, our chapter, which shows the thrust by area. What is the total force acting on a unit area of the body, right? Is called pressure. Pressure is measured in either Newton per meter square or Dyne per centimeter square or Pascal or bar or torr or atmospheric pressure. So many types of pressures are there. Right? And we have seen the applications also. The 5 applications given here. What are the applications of pressure? Starting from camel, how camel is walking comfortably over the desert, which is not possible with either horse or donkey or even human being. How skier is skating on ice with their skies, which are very big in area. How a truck containing 8 to 10 wheels, set of wheels, can travel on road comfortably without more pressure on ground. All these are because of the pressure. Right? So next class, when we come, we'll discuss about the how liquids and gases exerts pressure along with solid. Okay. Then we'll conclude the chapter with the only one more Pascal's law is there, very important, which is based on the pressure only. Of course, when you go to the higher classes, 9th and 10th, you can learn so many other laws like Bernoulli's principle and many more will come across where the pressure can be applicable. Right. So that's all for today. Thank you, students. Have a wonderful day. Thank you.